Welcome to LabTechs. My name is Nasir. Along with me, Dildar sir is here. Today we will understand what is the concept of reset and how do we check it with the help of DSO. My recommendation is to you that if you haven't watched the before video which you have been given, how you have to determine that your bias frequency is fine, you go and watch that video. PWM checking with the DSO, SDA, SCL, SM bus is checking with the DSO, RTC section with the DSO. If you haven't seen as of now, go back and see first of all that video, because this is the last signal which we need to check on the motherboard, and which is the reset signal. And this what is the advantage of checking this signal with the help of DSO, because you cannot identify this signal with the help of multimeter. How? Let's come and see, and we know more about the DRAM reset signal. So come, this is the motherboard which I have also described you in the PWM section and in the SDA SCL communication. Also we have 6th and 7th generation this model. This is the Lenovo Yoga 500 series LAC851, and first of all I would like to show you, or I would like to demonstrate you the reset signal in this model. And one more thing, I would like to give you a clue or where you can find the reset point on the motherboard. Two things you need to remember here, that even if you don't have the schematic, but by knowing this thing only, that you are having DDR3 slot in your motherboard on the 30 number pin. From here, like you can see, it is counted like this way: 1 2 3. It is written also here, okay, odd and even number, and 2 5 and 5 10 20 30. 30 number in the DDR2, whether it is low or high, 1.5 volt or 1.35 volt, the same point will be checked all time for the DRAM reset. But in the DDR4, what you have to mind, 108 number pin is dedicated for the DRAM reset in the DDR4 RAM slot. Like if we check in this model, like it is the LAD704P, it contains DDR4 RAM slot. So somebody has also tried to write it down in this way in order to find out some signals, because I have received it from my customer. He also repairs motherboard. So on the 108 number pin you have to remember in the DDR4 slot. So since this is the DDR3, so I have to put my probe on the 30 number of this RAM slot pin, and I have set my CRO on the capture mode, okay. And if you want to know that how to capture, go back and see the first video, the CRO setting video. There you will come to know that how to adjust, how to set for the capturing the signal. Let me check the signal. I am holding my probe, and as you can see that it is still on the X1, and also this is set here. All the setting is normal, only I have to capture. You can adjust. This is the horizontal position. I have adjusted it here so that I can capture if the reset is taking place somewhere. It is something like that. First of all, before jumping on the DSO, I would like to show you here. You see on the multimeter the same thing. Usually we hear in the groups, in the WhatsApp groups, and also many more people say that the DRAM reset is present in my board, but actually they don't know what is the concept of DRAM reset. So let me demonstrate you first. What do they think that getting voltage on this particular point is the reset? Now 1.5 volt we have got here, and we think that the reset is available here. So in fact this is our misconception, because this is just a carrying voltage which is carrying the reset signal. from the processor to the RAM supply. So this is the ultimate last reset of motherboard. As the beginning, as I have described you in the theoretical class, that the first reset is the EC reset, then after the RSM reset, then after the PLT reset, then after the GPU reset, then after the CPU reset, then after the DRAM reset. So this is the sequence of the reset you have been given in the theoretical class, all the information. Now this is not the reset, this is just a voltage which is carrying the reset signal, but the carried signal cannot be found on the multimeter. So that is why I won't suggest you to check the signal with the help of multimeter. One more thing. So now let me remove the RAM from the slot, and let me check it once again. So let me power it up and let me turn on the voltage. As you know that the pull up voltage is 1.5 volt DDR voltage, which is also known as the VDDQ voltage. And as you know that when the VDDQ voltage is generated in the motherboard after getting the SLP S3 voltage from the PCH. So let me turn it on, and you know that after turning on, all the process has executed, and RAM IC has reduced 1.5 volt for the DDR3 RAM supply, and the same place the DDR RAM reset is pulled up by 1.5 volt. The same voltage I was getting with the RAM slot, with the RAM, also without RAM we are getting the same voltage. We cannot differentiate between both. Once again let me show you. Now see, you cannot examine anything in this point that you are getting the 1.5 volt, but what is the advantage by checking the DSO? The reset signal is something which is, as I have described you in the theory class, that what actually meaning of reset is that on and off and on. So if it is on, and it will go down signal, the lower signal, the high signal, low signal, and again high signal. Then check it on the pin number 30. Let me put it off and let me turn it on. You can see, and after pressing the power button, now you see this is the point where my S0 voltage is generated. This is the point, and after that the reset should be here. So let me make it confirm by adjusting this way. Okay, so I think that somewhere else it is getting reset. So let's check it once again. So in this way we adjust. So let's check once again. As I have adjusted it to the last limit, now no reset is taking place, just because reset will be executed when it get the RAM card on the board. So there is a RAM card is missing in the slot, so CPU is unable to find the reset signal. So it is not resetting anything because it is not getting any RAM module in the motherboard. Okay, I am fixing the RAM module in the slot, and let me do the same once again. So it is the capture mode, it will capture the signal. Now you can see that this is the place where my S0 state generated in the motherboard, and as I have set it, now you can adjust it like that, like this point. Now you can see that my division is set on 50 millisecond per division. So you can calculate it: 50, 100, 150, 200, 250, 300. After around 300 millisecond, it is getting reset by processor. So this is the timing diagram. So if you follow the schematic diagram, then you will come to know that after how long will it reset. Because after generating this power in the motherboard, many more things need to be happen, like DDR power good, and PCH power okay, EC power okay. So many signal will be generated in between. So After 300 millisecond, then the reset executed by the processor. So this is the symbol. If you don't get even after you using the RAM module in the RAM slot, if you don't get this reset, this is actually called the reset signal, not this one. So this is just a carrying voltage which need to be reset by the processor. So after that you get the bunch of data you may not get as per the processor, as per the processor clock. It may be embedded clock, it may be the blue clock, it may be the green clock, so it could behave differently. You have to careful about this thing. If no reset is taken place, then you can think that there is something wrong. Maybe your RAM is not taken by the motherboard, your RAM is not detected by the motherboard due to some problem. Problem could be in your BIOS, problem could be in your PCH or processor communication. There could be problem between the RAM and CPU communication. So if you want to know more about this, you just go back and watch the theoretical video between the communication. So this is the one motherboard I have demonstrated you. So now let's come and check once again after putting the RAM module into the RAM slot. So let me show you on the multimeter. 30 number pin I am checking it with the multimeter. Now you can see 1.5 volt, but you cannot capture anything, or nor you can adjust it, nor you can examine it. Not at all you can do with the help of multimeter. Earlier you were getting the same, and sometime you get some variation, but you cannot make it confirm. Moreover, the one more fault you can get on this particular point, that sometime if you are getting the glitch line like 1.5 volt with the glitch, you cannot identify with the help of multimeter. So here, as you can see on the DSO, that a straight line is here, so it indicates that there is no problem in the power rail, and it is reset very fantastically, and after that the data has executed to the RAM module from the processor. So I think this is enough for this board. Now let me demonstrate you the same thing in the different motherboard. So why I'm checking like this, because maybe a different processor, as I have told you that different processor support different kinds of variation. As I have told you, this is the Yoga 500 series model, and which is having 6th or 7th generation processor, and the same DDR3 slot I am only available in my my setup, and that board is not getting on, so I have to work on that. Otherwise I could have shown you the DDR4 as well. So now you can see still my DSO is on the capture mode. Something has gone wrong, and what was the wrong? That the ground reference I forget to use. Now let me set it back. You just have to come out by pressing the run button. On the pin number 30 I am keeping it. Now I have adjusted my on off switch by connecting this jumper wire. Now something happened over there. Let me adjust it this way. So what I need to do, that this is the M pause, you can keep it here in the mid of the origin. So let me drag it to the origin. So it has reached now. So let's do it once again. So I am holding my probe on the pin number 30 of DDR3L. Now let me turn it on. Now you can see here what I need to check here, that now you can examine, you can bifurcate, you can adjust voltage, any type. Timing I have to first see. The time is 50 millisecond. Now you can see after around 70 to 80 millisecond, the same thing is happening here. So what is the difference between the that was the i3 third generation, and this is the sixth generation board? So what is the difference? That it was taking time, because as you know that the board I have checked, after 300 millisecond the reset was executed, and in this board only 80 millisecond has taken to executed the DRAM reset signal. Why does it happen? Because it is the it is the i3 or i5 second generation, and this is maybe the third generation, or both are the same. It is the sixth or seventh generation. So as you know that the PCH is embedded with the processor, and now let me show you one thing, so that you will come to know that why does this happen, that sometimes you vary the timing and sometimes you vary the clock signal as well. Now you can see that this is the, in the matter of generation, you can see that it is the sixth or seventh generation, and this is the processor and this is the PCH. Inside the processor, the regulator which is called that the VRM, internal core, the power chip of the both IC is very near to each other. So it is around 14 nanometer. So it communicate very fast. Also one thing you have noticed, like 3.3 and 5 volt regulator. So each and everything is embedded in the IC. So here there is no MOSFET. However, you are getting the MOSFET of 3.3 volt and 5 volt in this motherboard. It was taking time. There was the distance between the pin to the gate. So these new feature has reduced the time, and it executed very fast. So this is overall the reason, and all the IC you have find here that there is no MOSFET at all, and also the distance of the PCS to the processor communication has been reduced to the 14 nanometer. So this is the reason that in 80 millisecond you are getting your reset. So timing has been reduced, and that's why you are getting your newer laptop, you are getting at the fast speed. So this is all about the reset. And as you were watching the first demonstration, that after that the data was, or the clock was, you are getting on this point was the bunch of data. Now here is the very less amount of data you are getting. It could vary as per the internal clock in the PCH. So this is all I wanted to say you here, that after some moment you just don't have to run after the timing. Only you have to watch that, let it be fall down. Otherwise the reset is not executed in your motherboard. Or you can consider it that lacking of some power supply, or lacking of some clock signal, or there must be a fault in the BIOS section, or BIOS IC is faulty, or BIOS program is faulty. Due to any reason, you may not get the reset signal on the reset pin of the RAM module. So that is why you have to be very careful, or without RAM slot you have not to check the reset signal. You all must have to use the RAM module in order to check the reset signal. If you have any query regarding the reset signal, then you can ask in the group. Thank you guys. Thank you for watching this video.